Yeah. So my name is Chris Nicholson. I'm the CEO and co-founder of Skymind. Skymind is a 3-year-old company. We're an open source software company, and we built something called Deep Learning for J. So Deep Learning for J is an open source deep learning framework. It's the main framework of the Java language. And the way to think of us as a business is we're Red Hat for AI, right? We're Cloudera for deep learning, which means we support our own open source software and the solutions that are built with that software, right? So if you know, I'm just going to draw on the whiteboard a bit, but if you, how many people here have worked with Red Hat or who have heard of Red Hat Enterprise Linux, RHEL? Yeah, okay. So Red Hat is the world's largest open source software company. It's worth about $12 billion, and it has an enterprise distribution of an operating system. It's called RHEL, Red Hat Enterprise Linux. So I'm going to use them as an analogy to explain our business. So here's Red Hat. Here's Linux, that's the open source stuff, and there's RHEL, that's the enterprise stuff, okay? So here's Skymind. Man, this is a red pen that's not working very well. So here's Skymind, here's Deep Learning for J, and what we support, our enterprise distribution, is the Skymind intelligence layer, right? Which bundles Deep Learning for J, just like Red Hat Enterprise Linux bundles Linux, right? Now every open source software company in the world works pretty much in the same way. So they sell support, they sell services, and they sell training. I'm going to talk about each of these. So services, professional services, are consulting, right? That means if somebody doesn't know how to build an AI solution, or if their team doesn't have the time, we will do it for them. We go into the enterprise and we build that AI solution with our software, and then we tell them at the end, if you enter into a support contract with us, we'll make sure it keeps on working forever. Right? So we're basically an insurance company, right? And all open source software companies are basically insurance companies, right? We're selling warranties on our own code. So if any of you have bought a car, you probably bought insurance on that car, right? And that insurance allows you to drive the car into the garage when it breaks, right? That's what we're selling with support contracts. We give people the right to drive it into the garage to fix those AI solutions. And then finally, we sell training, right? Which means that my instructors go into these businesses and they teach people how to build AI. So that's our business model. It's mostly services, as you can imagine, because most companies in the world don't know how to build AI, right? I'm going to actually show you. Sorry, I'm having technical breakdowns with my eraser here. So I'm going to show you how the market breaks down, okay? The market breaks down like a triangle. The triangle has 4 tiers. Now, in this first tier are companies that have spoken here today. Google, Amazon, Microsoft, Facebook, right? These are the top AI companies in the world, right? And the reason why I know they're the top is because they built their own deep learning frameworks. Yeah, they built their own deep learning frameworks, and on top of those frameworks, TensorFlow, PyTorch, MXNet, they're building 10,000 solutions. So if you're Google, you're calculating the conversion rate, the CTR, the click-through rate of your ads. And that's adding hundreds of millions of dollars to your revenue each quarter, right? Google's having blowout quarters because it's applying AI to its ads, right? If you're Amazon, as Hassan said, you're applying that to logistics and fulfillment. You're making a more efficient operation for yourself. So these are the top AI companies. We don't work with them because they don't need us, right? These people have built their own AI and they're consuming their own AI. They're dogfooding. Now, one level down, that's tier 1. Tier 2, one level down, you've got the Wall Street banks and companies like eBay, right? Companies like eBay have a bunch of data scientists who can build machine learning solutions, but they should be using somebody else's tools, right? So they're adopting our tools and they're adopting Google's tools and Amazon's tools, and they're creating algorithms that make their businesses more money. But they have no reason to maintain the hundreds of thousands of lines of code in TensorFlow. They shouldn't do it. It doesn't make any sense, right? So the quant teams in Wall Street banks or the teams of data scientists in kind of the major but not cutting edge companies like eBay, right, are going to be using these tools. And what we do is we sell them support. We don't have to sell them services. We don't have to sell them solutions. We just say, we'll back you up if you use Deep Learning for J, right? Now, tier 3. This is where you start getting a lot of companies, right? Tier 3 are companies that have built their own big data stack, right? So they know how to gather, move, and store data, right? But they don't know how to build machine learning yet. So they have a bunch of data engineers, they have a bunch of data, and they have clear needs. They know strategically why they want machine learning, but they can't get there themselves. So that's where we'd sell training, or we would just go in and park on top of their big data stack, right? And we would add AI to the top of that stack. Finally, this looks like an isosceles triangle. In fact, this last tier has a very long, thick tail. This is tier 4. And these are the companies that have outsourced their big data management, right? So the companies that have outsourced their big data management are using SAP HANA, for example, and they really don't have a clue what they've got. They don't know what they've got, they don't know how to manage it, and yet they think that AI would be cool, right? So for these companies, I usually have to say, come back to me in a year, right? And in a year, you should do these things like use Hadoop, use Spark, use Kafka to get yourself into tier 3 where we can help you, right? So that's how the AI market breaks down, right? And the opportunity for a company like Skymind is in tier 2 and tier 3 for the most part. I'm actually going to tell you a personal story and a true story about Skymind today, and then I'm going to tell you some stories about the companies we helped. So in 2013, I moved to Silicon Valley from Paris, France. And I had spent 10 years in Paris as a foreign correspondent for the New York Times and Bloomberg News. So I'm a former journalist, and I apologize. But I moved to Silicon Valley because journalism was shrinking, right? It's an industry in distress. Being a reporter is a lot of fun, but tech is the world's main growth industry. So I decided I wanted to be part of that. I moved to Silicon Valley, and I moved into a hacker house. How many of you here have seen Silicon Valley, the show, on HBO?
Yes.
So you know what a hacker house is, right? It's a reservoir of spare beds, right? It's a reservoir of spare beds in San Francisco and Silicon Valley for people who can't find an apartment in the crazy real estate market, right? Because Silicon Valley is creating hundreds of thousands of jobs per year, but it's not creating hundreds of thousands of apartments. Right? There's nowhere to stay. There's nowhere to live. So I moved into a hacker house. I was in one bunk in a room with 5 other bunks and 5 other snoring guys. And my co-founder, Adam Gibson, was one room over, and he had his own bunk and he had his own snoring guy problem. Right? So we arrived there within weeks of each other, 2013, and I went straight to work for a Sequoia-backed startup called Future Advisor. Now, Future Advisor is an automated investment manager. How many of you have heard of a robo-advisor? Do you know what that is? Yeah, okay, great. So a robo-advisor is a financial advisor that uses an algorithm to automatically balance your investments between equity and debt, for example. So there are some big ones like Wealthfront or Betterment. In the UK, you have Nutmeg, right? So you've got them on several continents, and I was their PR guy, because that's what journalists do when they leave journalism. They go into PR. I joined as employee number 10. I became their PR guy, and pretty soon they made me do recruiting too. Right? I told them I don't know how to do recruiting, and they said that's okay. That's okay, because if you don't, you can't really screw up in this job, because if you do nothing, nobody else will either. So, and that's how startups work, right? You go in, there's 10 other people, and you wear many hats at the same time. So I was learning PR, I was learning recruiting, and Adam was thinking about machine learning. Right, so in 2013, I'll give you a little history of kind of recent history of machine learning and deep learning. In 2013, Google hired Jeff Hinton. And Jeff Hinton is probably the world's most recognized, most prominent deep learning researcher. Right, he came up with restricted Boltzmann machines, and he and his students started setting records in both speech-to-text and image recognition back in 2006, 2009. Right, so Google hired Jeff Hinton. A few months later, Facebook hired Jan LeCun. And that was an earthquake in the machine learning world, right? Because everybody in machine learning saw that the world's 2 most advanced technology companies had hired the 2 most prominent researchers, and they were paying them a lot of money. And we all started asking ourselves, what are the business applications for this technology, right? That hasn't really become well known in business yet, right? It's different today. Obviously, you're all here. We've all heard of deep learning and neural nets. But 10 years ago, neural nets were spurned. Jeff Hinton couldn't even get published, right? So there's been a huge shift in the way people think about deep learning. And in business, it started in 2013. So my co-founder, Adam Gibson, he started building this thing called deep learning for J, because there were no open source tools for Java. And Java in case you don't know, is the world's #1 programming language, right? There are 10 million Java programmers. Most of them work in corporate IT, and most of corporate IT is in Java, right? So if you're thinking about databases, for example, if you're thinking about website backends, it's all Java stuff. And there's a ton of applications for machine learning there. 2014, Adam and I looked at each other, saw the two hardest working guys in our co-working house. And neither one of us was big head, to use the analogy of the HBO show. And so we decided to team up, and we founded Skymind. And I started knocking on doors trying to raise funds. And I'll tell you, I spent about a year doing that. It took me a year to raise funds because because first-timers in Silicon Valley have a hard time. You need a product to show, or you need a Stanford degree, right? So it was a long, dry year for us, but because of PR, I got Adam, this 24-year-old kid, a spread in Wired, right? Which is to say, we got into America's biggest tech magazine, right? This guy who came out of nowhere. And Tencent saw that, and Tencent came and gave us money. Right? That was our first $200,000, and we looked at that money and we thought, okay, with this I'm going to raise another 10 million, and then we'll be golden, right? That $200,000 was all the money we raised in 2014. However, we got our first client a few months later. That was an Asian cell phone maker, and they were paying for training, and they sent us a $50,000 check. And when I got that check in the mail, I thought to myself, we are going to be billionaires. We're not billionaires yet, right? But we got into Y Combinator that fall. And so a year later in 2016, we came through demo day and we raised a $3 million seed round, right? And now we're a 35-person company, right? With engineers in 8 different countries and over a dozen large enterprise clients, over 5,000 developers in our user support channel. And so we've really gotten to know the problems that enterprise has making deep learning work. And I'm going to tell you about some of those problems now. So there's a large aviation company in America. I won't name it, but you can probably guess what it is. And it has a major unit that creates parts catalogs, right? Now, parts catalogs are catalogs that update the parts that are in airplanes, right? So you can imagine airplanes have tens of thousands of parts, right? And you can also imagine that just like everything else in the world, those parts become obsolete, they become updated, or they become entirely replaced. And it's hugely important that the mechanics fixing those planes know when one part is updated or replaced, so they can fix a plane that's broken, right? So this unit of an aviation company has a problem, and the problem is that they employ several thousand people to read reports about parts that need to be updated. They employ several thousand people to read these reports. It takes a lot of time, and they make a lot of mistakes. So the CTO basically looked at his company and he saw a dying company, right? Just like I looked at journalism and I saw journalism dying. And he went to his board and he bet his career, right? He went to his board and said, if you give me this money, I will make machine learning work for our unit of Boeing. And if it doesn't work, you can fire me, right? And after that, he went to go find a team who could build him AI. So he found us last year. We built him an AI backbone. We have models deployed in production, and we've effectively insured his unit of Boeing against the future, right? Against the secular decline that they were facing, to the point where we're looking at dozens of other use cases within this unit of Boeing. And so that's actually a lot of companies in the world are exactly like that, right? They know they're dying. They can look at Silicon Valley and see companies like Google transforming themselves and taking enormous leads in huge markets. And they don't know how to cross the chasm, right? From the gradual decline they're suffering to the place where they have an AI backbone. And what we do is we say, we'll build you one. And actually, a lot of it's just in open source. You can download it for free. Now, the people here today may have heard from other folks who are talking about other open source libraries, right? You've heard about TensorFlow. You may have heard of CNTK. You may have heard of MXNet. Now, I'll tell you what distinguishes our open source library. We're the dominant library for the JVM, right? We're the dominant library for the production stack that most companies use. And the reason that's important is because most of data science happens in Python, right? And most of data science never leaves Python, which is to say, most data science never gets productionized, right? It never makes a difference for the companies that are employing those data scientists, right? And what we offer them is a bridge between the world of Python and the world of the production stack, right? We offer them a tool that makes them valuable to their company in an immediate and visible way, right? Because if they're not valuable in an immediate and visible way, they're going to have a lot of hard conversations with their managers. So I'll draw a little picture for you. If I can find a pen that works, excuse me. Maybe I'll do it on here. It's helpful. How many of you here work in data science? Show of hands. Not too many. Okay. How many of you here are managing in companies or working with data scientists and wondering how you'll implement AI in your companies? Okay. That's great. I'm going to make this talk slightly higher level from now on. And technical people will have to forgive me, but we're going to talk in some general terms. So what I'm going to do is I'm going to show you the big data stack, right? What it's made of and where AI fits in, and ways to think about how AI can help you, all right? A big data stack is like a chemical factory, and data is like a fluid moving through that factory, right? So what do you do with fluids? You gather them in a funnel, you move them through a pipe, you store them in a bucket, right? And then once in a while you filter them. AI is the filter, right? AI tells you what's in your pipes and what's in your storage, right? It's actually the moment that gives meaning to raw data. So we'll talk about this for a second. What are your funnels? A funnel is a place where analog reality becomes digitized, right? Right now, we're all in analog right now, right? There's a haze of photons entering your eyes. Your brain is saying, that's Chris, right? Well, that haze of photons has to be digitized first. It could be in a stream of web logs. It could be server logs in a data center, right? It could be in IoT sensors. This gets digitized, moved through a pipe like Kafka, right? Or Flink or Storm. Have you heard of Kafka and Flink? These are streaming engines. These are message queues. They move data from say, a website to a bucket like Hadoop, storage like Hadoop. And just so you know, these tools are all on the JVM, right? That big data stack, it's JVM, and that's where we live. And that's why we created our tool. So you got this big data stack, you're dumping stuff in what they call HDFS, right? And that's as far as a lot of companies have taken it. But the ones that want to build machine learning solutions have to take an extra step, and that's where our work begins, right? It starts right there, and it starts at a step that we call ETL, right? Extract, transform, and load data. So another word for it is data preprocessing. So extract, transform, load. What does extract mean? It means we're scooping it out of storage, right? Transform means we're applying mathematical operations to it and computational logic to give it a new shape. I'll tell you what the shape is in a moment. And then load means we're putting it into the neural nets, because neural nets actually only understand data in certain shapes. So that shape, the basic data structure of machine learning is called a multi-dimensional array, right? Or a tensor. So, and that's why Google named its tool TensorFlow. Let's do a quick primer in linear algebra. A vector, as you may know, it's like cells in a spreadsheet, right? It's a column of numbers, 36, 102, right? So that's a vector. If I add another column to it, all of a sudden, I have a two-dimensional array, right? Just like a spreadsheet. What if I stack my two-dimensional arrays, right? Then I've got a cube, right? And as soon as I have a stack of two-dimensional arrays, I've gone into tensor land, right? That's where the word tensor becomes useful for us, right? Because most people don't have a word for that. And I can keep on stacking them. So I can nest these things, right? I can make every single one of these numbers a nest, and all of a sudden I've got a four-dimensional array, right? And I can keep on nesting them inside until I get to 500 dimensions, things that humans can no longer visualize. All of that's a tensor. It's if we don't put a limit on those dimensions, it's an n-dimensional tensor, right? And that's why we built a tool called ND4J. ND4J, n-dimensional arrays for Java, is the most performant and maybe the only tool on the JVM that can handle these tensors, these n-dimensional arrays, right? Which are necessary if you're going to train neural networks. So we're taking these tensors, right? We've transformed text or images or sound or time series data into these tensors, and we're loading it into our neural nets. So this was the ETL step. Now, everybody talks about training neural nets. How many of you know what that means? I'll tell you. A useful analogy is a child. A child is born ignorant, right? It knows almost nothing of the world. You could say its brain is randomly initialized, right? And through exposure to data, it learns how to interpret the world, right? So an infant, through exposure to the world, begins to navigate it, like doesn't bump into a tree anymore. A neural net properly tuned can learn the structures of data, right? Depending on the objective that you ask it to accomplish, right? So it can learn to categorize data, it can learn to cluster data by similarity, it can learn to make predictions about data. So that's training, right? Now training requires either a lot of time or a lot of hardware. And hardware is just a way to parallelize time, right? How many of you have seen the movie Her? Right? Okay. So, and do you remember how she started learning faster than the guy? That's because she had a bigger brain and the capacity to live thousands of lives at the same time. Every neural net is like that. It has the capacity to live much more than us, faster than us, right? Which is why an algorithm like AlphaGo can beat the world champion at Go, because it's actually played more games than any single human in the world can ever play, right? It's not that these algorithms are inherently smarter. It's that they're able to experience more in a more accelerated fashion. So training is all about acceleration. Get them smart as fast as possible. The way you do that is a library called Spark, right? People have heard of Spark? Yep, okay. Spark is air traffic control, right? Spark is coordinating the work of many chips at once. Those chips could be GPUs, right? They could be CPUs. They could be heterogeneous, all mixed up together. Now, all that means is that you can take a ton of data and you can shard it over many chips at once. All those chips send their results back to a master, right? Which gets smarter each time, and then it updates each of these slaves until you finally have a smart model. And that smart model puts out results, right? And actually, you want to take that smart model and you want to put it somewhere. And this is where we come to the final stage of the machine learning workflow, right? This is inference. So inference, you might also call it scoring. We call it deployment, right? Inference is where the rubber hits the road, right? So training is in the lab, right? Inference is where you allow your model to touch real data in real time, right? That's where you produce value for your company. So, and the reason why I'm giving you this talk today is to talk about things besides training. I'm here to talk about ETL, and I'm here to talk about inference. ETL is 80% of the work, and inference is 90% of the value that machine learning can give you. And nobody really talks about them, right? Everybody's talking about how my neural net produces better results, right? 99% accurate, right? I submit to you today that ETL and inference are actually much more important, right? You want to be able to transform your data quickly and scalably, right? Most Python tools just ask you to create a kludgy one-off data pipeline, and you want to be able to deploy it in a scalable way, right? So let's talk about that inference stage for a second. Everybody here knows what a web server is, I assume. Yeah, okay. What does a web server do? A web server takes an HTTP request and it returns information about a website, right? So you got your little laptop computer and you've got a server somewhere, HTTP in the middle, right? And data goes back. Well, guess, and this structure is what makes the modern internet possible, right? Web servers. Now, in AI, we have something called a model server. So, can you guess what a model server does? It takes data from a data source. Let's say you're scooping it out of HDFS, or you're streaming it from a website, right? And this is your AI model. You send your data over here via JSON, and you get a decision about it back, right? And this is basically a schema for how AI works in production, right? AI is just math and code over there. You submit the data, you get decisions about that data. Now, if you're dealing with high volume, real-time data, you need something that's scalable. What does that mean exactly? Just like with a web server, if I take out an interview during the Super Bowl, I'm going to get a surge in traffic to my website, right? Now, I can just continue to use one web server and have my web server break down during that commercial, or I can copy it. I can make replicas of it, and I can distribute the traffic, right? AI, model servers in AI should work the same way, and ours does, right? So when you get a surge in data traffic, we copy your AI model, we distribute that data across the model so that we can return decisions about the data with the same low latency that you got when there wasn't high traffic of data, right? So like I said, if you don't have a model server that can handle high traffic, you're not doing AI for production, right? You're still in the lab. So these are the things that you should be thinking about. How do I scale it? How do I ensure that it doesn't break down, right? How many of you here know the difference between AI, machine learning, and deep learning? Who's confident that they can explain it? Go ahead, sir.
Machine learning is applying algorithms to get insights, to get insights.
Yeah.
And artificial intelligence is maybe, in a broader sense, when we will reach something at a higher level, so not something that we can do today. That's the general one.
Yeah.
What was the other?
Deep learning. Deep learning.
Deep learning is when applying the web propagation algorithms with a network that has different layers.
Yes. A lot of what you say is true, and I'm going to draw a picture and kind of draw it out. So there's different ways to think about AI, right? And we usually distinguish them through the use of adjectives. So we have narrow AI, and we have strong AI. And strong AI doesn't exist yet. That's the kind of AI you were just talking about, right? But AI is also just the name of the field, right? Like all machine learning is actually AI. It's just narrow AI, right? So we've got machine learning there. All machine learning is AI, but not all AI is machine learning. What's an example of AI that's not machine learning? Expert systems. Who's heard of an expert system, right? It's a rules engine. So it's a bunch of if-then statements. So in America, for example, if I have $10,000 cash and I walk into a bank and say, I want to deposit this, the law says the bank has to report that to the government, right? So a rule system would say, if 10K cash, then report to government, right? Now, thousands of these if-then statements together are a rules engine, right? They reflect hard, deterministic relations in the world. What they don't do is they don't learn, right? And that's why machine learning distinguishes itself, because machine learning algorithms can actually adapt to the data they're exposed to, right? So I could run this little thing 1,000 times, 10K, report to the government. It's never going to change. It's static, right? That's an expert system. Machine learning is dynamic, right? It rewrites itself in response to the data. And then finally, deep learning. All deep learning is machine learning, but not all machine learning is deep learning, right? Because a lot of machine learning isn't using back propagation, as you said, right? It's not a deep neural network. Now, deep is actually a technical term. Each of these words means something, right? Learning means it's dynamic, right? As opposed to the rest of AI, which is static, right? Deep. You probably saw some of the drawings that Marcello and others use today, where you have a bunch of little nodes, right? And you have a bunch of mathematical operations going through the layers. Did you see some of those talks? You saw? Okay. So deep learning, the depth of the neural network, this dimension, that's deep, right? So when you have a lot of these, in fact, if you have more than 2 of these interior layers, or 2 or more, you've got deep learning, right? And you can go to 150 or thousands if you want to, right? So that's when people are talking about these terms, that's the easiest way to distinguish them, right? Now, when people are talking about AI in general and how they can make it useful for their company, what I'm going to try to do right now is I'm going to try to teach you a way to clarify their thinking, right? To bring a schema of AI back to your own companies to help people understand what AI can do and what it can't do. So let's go back to that. It's almost blindingly simple. It may look so simple that it's dumb, right? But AI is just this math and code in a box. The data goes in, the decisions come out, right? So let's say you're in a company and somebody says, we should add AI, right? I get that all the time. We get those calls. Can you do AI for us? Okay. Well, the first question I ask them is, what do you care about? Right? What decisions are important to you, right? They may say, well, I want to know what my business should do next year, right? That's a hard problem to solve. We're never going to solve that for them. But if they give me something more narrow, like we're trying to build fraud detection, or we want to build a facial identification system, I can do that, right? So what does facial identification mean? It means that I'm applying names to data, right? That's what's called a classifier. So Or maybe they say, I want to build image search, right? I want to detect similarities between images. That's a clustering engine, right? Or they might say, I want to predict the next thing that somebody's going to want to buy, right? And there you're making predictions about transactions, let's say. So these three things, when you're talking about what decisions do you care about, what outcomes matter to you, the key thing is to break it down into one of these types of problems. Are you trying to classify something, put a name on it, right? Are you trying to cluster it like nameless grouping? For example, if we took the pictures of everyone in this room, right, and we trained a neural net to group them, all the women would appear in one corner, and the men would pretty much appear in another, right? Maybe we'd be sorted a little bit by age. So it's those kinds of groupings, right, that neural nets can detect, even if you don't tell it this is a man and this is a woman, right? So clustering or predictions. So as you go back to your companies and you try to figure out how AI can be useful to you, it's useful to introduce these notions to the people around you so they know we're building a classification engine or a clustering engine or prediction. Okay, the second big question after you kind of reach strategic consensus about what you want AI to do is to figure out whether you have the data, right? That's the second big question. So if somebody comes to me and they say, I want to know what my business should do next year, right? The reason why I can't do that is because I don't have the data for that, most likely, right? They probably can't supply it to me. But if they said, I want facial identification, that's easy. I'll just go take pictures. Or maybe you can give them to me, right? And it will not be hard for somebody to put names on them, right? So if I'm doing a classifier, what I need is a labeled data set, right? Preferably lots of them and high quality, right? If I don't have that, I can't do a classifier, but it's easy to build, right? The gentleman from Amazon was here. They have a service called Mechanical Turk. There are other companies in Silicon Valley, Crowdflower, Mighty.ai, right? They offer services where for a few hundred and sometimes a few $1,000s, you can create a high quality labeled data set. And on top of that high quality labeled data set, you can build a classifier, right? And that's where AI starts. That's where the work of AI starts. And if your company is not serious about getting the data right, they're not serious about AI, right? You should circle back to it once they feel a lot more urgency, right? That's the first step. So if there are times when you can't label things, right? Oh, 5 minutes, great. Actually, you know what? Why don't I open this up to questions? How about that? Are there any questions? And if there are none, I'm going to keep talking at you. Yeah?
Is that every company that needs AI, or, I mean, not everyone, not every company. Because
Yeah.
you said it's like an insurance, you're creating an insurance for the future of your company.
Yeah.
You made some examples.
Yeah.
But I wanted to understand, do you think does it involve all the companies?
Sorry, my pen is falling apart. Technical problems with the whiteboard. Right now, not all companies can do AI, right?
Yeah, of course.
So the ones that can't do it shouldn't think about it. But I can tell you what they need, right? So you can determine for yourself whether it's even worthwhile talking about it. So you need 4 things. You need team, you need tools, you need data, and you need infrastructure, right? So the team is your data scientists or your data engineers who you can help, who you can teach to tune algorithms, right? Obviously, the big tech companies, Google, Amazon, they've got it. A lot of startups don't have it, right? And they're not even ready to start hiring for it, right? Because there are other things that they need to get first, right? So this team needs to use certain tools. Those tools can be Deal4j, they can be MXNet, they can be TensorFlow, right? Really you should get the tools that integrate with your team's skills, right? And the team is hard to find. They're rare, right? You end up paying them way too much money. As the data scientists in this room may know. And next, you need the data, right? It's that labeled data set that I was talking about. Without it, you can't build a classifier, right? And finally, you need the infrastructure. Now, by infrastructure, I mean a place to store the data, maybe the chips to train the neural nets, like GPUs, for example. So those are the 4 things. There's a lot of startups in Silicon Valley who are nowhere close to being able to put all this together, and they should focus on something else, right? And maybe they should focus on one of these at a time. Like, let's gather the data that we're going to need, right? Because any one of these things, how can I say, all of them are necessary, and no one of them alone is sufficient, right, to give an AI solution. Do some companies not need AI? Sure, you know, like, or I should say, it's probably not worth thinking about yet. But the industries where it is worth thinking about are the information-rich industries. So we feel at Skymind the most pull is coming from telecoms, banks, e-commerce, and healthcare, right? All of those sectors are sitting on enormous amounts of data. And in telecoms and banks, for example, they basically consider themselves information processing companies, right? Like, they're made of bits, right? They don't have a lot of stuff to sell. So the better they handle those bits, the smarter they become, and the more they have an edge over the competition. Does that answer your question?
It does,
yeah?
Because
okay.
We actually, what I feel for my startup, which is a marketplace that helps babysitters finding a job and parents finding a babysitter.
Yep.
It's last year we focused on tools.
Yeah.
We implemented Salesforce.
Yep.
And actually, after a year now, I can say that it's helping us a lot.
It's helping.
It was
great.
really difficult because it was new and it was not actually fixed for us. You know, it was not proper, but now it is, and it's working really well. And now this year I can say we're focusing on data, so we're getting into it. And
great.
So what you said, it did answer.
Great. Cool. I also, every company faces a question, and the question is, should I build or should I buy, right? And you guys chose buy with Salesforce, and for a lot of almost any company starting out, that's the right decision, because building it yourself is a huge undertaking. It took us 3 years to build what we've built, right? So the way most companies will encounter AI is it's going to be a component in some other product they buy, right? It's going to infuse somebody else's product. Like, if you have a self-driving car, right? You're encountering AI, right? It's inside there, and you bought it, right? And you didn't have to think about, how do I add AI to my car, right? People shouldn't do that anyway. Yeah. Any other questions?
How do you keep pace with the big guys in terms of keeping the framework?
Yeah, you know, I think the right question is, how do they keep pace with us? No, really. You know, like what one programmer can do in 1 month, 2 programmers can do in 2 months. You know what I mean? Like, size is not an advantage in many software development tasks. So getting teams of hundreds of engineers together, we see this with IBM, right? IBM's having real trouble building the tech to enable AI in companies. And I think they threw too many people at it, right? They're throwing thousands of people at it. And those people are just getting in each other's way. Yeah. Yeah.
Hello. Hi. I'm Sebastian. I am the managing director of PiSchool, who's been bringing this video to you. And now taking over from Chris, taking over the floor from Chris. This was a recorded video, we recorded, it was end of 2018. It's obviously got many elements that are still very current and many others which are which have changed in the meantime. So I want to give you a bit of an update of what's happened to Skymind in the meantime. And then I want to open the floor for our questions and answer them live. So, the very month that Chris recorded the video when he came to Rome to visit us at PiSchool, Skymind made Deep Learning for J an open source contribution to the Eclipse Foundation. It was back in October 2017, sorry. And so in that fashion, Skymind became a member of the Eclipse Foundation, which is a very big open source foundation for the Java world, the enterprise world. We brought, to give a bit of context, maybe we brought this video and we invited Chris because as PiCampus, we have an investment. We used to have an investment in the company Skymind. PiCampus, which is where I am from. PiCampus is a seed venture fund, which means we invest in AI, in applied AI startups, to be specific. We currently have 49 investments. About half of them are startups which have their headquarters with us in Rome, in the Eur district, and the other half is spread throughout the world. So Skymind was one of the companies that we invested in as part of our co-investments, frequent co-investments, I would say, in Y Combinator. So Y Combinator is the world's most successful accelerator for startups, Silicon Valley based, and PiCampus regularly co-invests with Y Combinator. Skymind was one of these investments. In the meantime, Skymind has been evolving. So it's received overall over its lifetime, I would say until late 2019, it's received about 20 million investments, most notably from companies around Tencent and funds from Asia and Southeast Asia. And after after this time, so the turn of 2020, it received a very large investment from a Malaysian-based family and became Skymind Global Ventures, which is now also an investment fund into AI startups and continues operation still under the name of Skymind, and has evolved, if you will, its business model quite a bit in the meantime. It's also, so due to that, Skymind Global Ventures is now part of the Eclipse Foundation, still offers a lot of training opportunities, both for enterprise and for individuals, and is a big player in the open source deep learning ecosystem for that reason, of course. And then another part of the company went another way, and some other employees, Chris among others, the person who just spoke, Chris, and other employees from Skymind continued their way into another business, Pathmind, which you can look up, which is still in operation, which operates, has taken over some of the employees of Skymind, and is starting a new model. So Pathmind is about using reinforcement learning, which is a form of machine learning, to essentially optimize industry processes. So reinforcement learning is a very special part of machine learning in the sense that it works by operating in an environment, making guesses about what the environment is like, performing actions and looking at the result of actions, and then updating what's called policies, carrying out other actions, and going on like this in order to optimize some quantity that is in reinforcement learning, that's called a reward. And that is an indication of how well the agent, that's what the algorithm is called, is doing in this environment. And so Pathmind is doing this kind of work, this kind of technical work applied to optimizing, for instance, factory flows, optimizing delivery sequences or order fulfillment sequences, so applied to manufacturing in general. And well, I think, yeah, it sums it up, right? So we have Skymind Global Ventures, we have the Deep Learning for J open source project, which found its way into the Eclipse Foundation, totally open source, and we have Pathmind. So this is how the company Skymind that that Chris described in this talk, with its businesses, configured like that of an open source based company, how it evolved. So it's quite an interesting story, I guess. And I wanted to tell you a bit about that. Okay. I will just say a couple of words about us, PiCampus, PiSchool, and then I'd like to open the floor for questions. We've got 15 minutes then for questions. So I told you, PiCampus is a venture investment fund. As part of its investments, PiCampus has created PiSchool, I'm the managing director of PiSchool, and I have another hat, if you will, still within PiCampus as the director of AI at Translated. Translated is a provider of professional translation services, a company that was founded 20 years ago by Marco Trombetti and Isabelle Andrieux. They founded Translated, which has been growing organically throughout the years, and threw off some profit, which they reinvested into PiCampus in order to be able to invest in new companies and startups. And they found that this was a really good vehicle for them to help young entrepreneurs, like they were themselves when they founded Translated. They were in their 20s, they were students. And they thought that this was really good to, in a kind of give back, so being able to reinvest in what young people are doing, young entrepreneurs with good ideas, and help them grow their business. So that's how PiCampus was born. Part of the insights that they made after founding PiCampus is something that became even, is now commonplace, but it's very obvious, is the lack of specialized AI talent, especially in Europe. And by that, we mean people who know how to build AI systems, not just from a theoretic point of view, which is what universities are good at producing this kind of skill, but also from a practical point of view. And that's how PiSchool was born. So at the beginning of PiSchool, I helped create what's now our flagship program, if you will, a program that we call School of AI, which is one where we're taking sponsorship from companies to work on challenges that they pose based on data that they own, and we develop AI solutions based on that. We do this, and the teams we work with are our trainees. So there are people with a background in AI, usually with masters or PhD degrees, even professors with a background in AI. And we help them work on these real life industry challenges by applying the latest, very recent AI techniques. So in AI, things move very fast. You probably heard that. But when you realize that the techniques you're supposed to apply to be top notch, and if you're not, then you're missing on something, that these techniques maybe have been published 2 months ago, then you realize how fast the pace of change is. That's how it really goes. Sometimes we end up implementing algorithms which are published during our 8 weeks sequences in which we do these rapid prototyping sprints. So we need to be watching out for these for the state of the art all the time, and we try and help the trainees who come our way to work on these projects by helping them acquire the skills to implement the state of the art. And so this is a program that we've been doing 7 times now, so 7 sessions. We're currently, next week, we will finish our last session of School of AI. Our 7th session of School of AI. There'll be another one starting in spring. And we have done 66 projects this way and trained 129 fellows, we call them, alumni, in these AI techniques. If your background is in AI and you'd like to take part in these training sessions, then you can apply on our website. It's picampus-school.com. And you can also, if you're a company instead and you're interested in seeing how we can help you solve your business problems with AI techniques in a very fast fashion. So that's really the thing that sets us apart. It takes us 8 weeks, so less than 2 months, to actually give you something in hand. Well, we can get in touch as well. You can get in touch with me, or you can go onto our website and ask for a meeting. Okay, spoken enough. I'm going to ask you if you have any questions. E possiamo fare le domande pure in italiano, quindi se volete possiamo proseguire sia in italiano che in inglese. E sono qui per le vostre domande, quindi fate pure, chiedete sia su quello che ha raccontato Chris che sull'industria delle AI in generale, o o magari su quello che facciamo in PiCampus, in PiSchool e così via. Sono come Chris, se voi non fate domande, continuo a chiacchierare. Aspetto comunque 1 minuto o 2, così che... And while I'm at it, I wanted to point out that we've got a couple more talks come up tomorrow. Let me find the link. Go. We're in this session here, and tomorrow, Sunday 13th, we have another 2 sessions still brought to you by PiSchool. So the first one, Sunday morning, is by Łukasz, who's a mentor at PiSchool. Łukasz is a member of Google Brain. He's one of the inventors of a very famous type of machine learning model called the transformer. The transformer is a model that is the building block for all the major advances in the last 3 years, ever since it was invented by Łukasz and colleagues, in what's called natural language processing. So that is essentially AI for language. And in this talk, Łukasz is describing this transformer model and explaining how it utilizes this very special thing, which is called attention, and especially self-attention in deep neural networks. Okay, in the afternoon, we have Alex Weibel, who's a faculty advisor for PiSchool, speak about multimodal language technology and AI. So he'll be speaking about much of the work that he's involved with, which is enriching linguistic exchanges with machines with more sort of, well, with multimodality, essentially, with other modalities than just text. Alex is a professor at Carnegie Mellon University, a veteran of AI, very good person too, and he's been founding 10 spin-offs during his lifetime so far. He became, in 2008, he became the first head of AI at Facebook when he sold Jibigo, which was an audio translation company at the time. And so he's got a lot to speak about from his work, from his scientific work here. Okay. So let me stop sharing. Okay, you have got no questions, but I'm still available. Beh, if you have no questions, then I have questions to you. For those of you who are willing to share that. Mi interessa capire da dove viene il vostro interesse in questa sessione. È perché è rilevante magari da un punto di vista professionale, perché vi interessa da un punto di vista, diciamo, umano, per capire gli sviluppi tecnologici, il loro impatto sull'economia e la vita delle persone in generale. Avete un interesse tecnico, perché vi interessa dal punto di vista di quello che è fattibile scientificamente, come questo invece intorno a un'applicazione nell'industria. Da dove viene in sostanza? Sono interessato a capire un po' questo. rispondete pure con una parola soltanto, se così mi fate capire al volo. Hello.
Please, my name is Michael J.
Hi, Michael.
Hello. I am new to this whole system.
Okay.
In your deliberation, you were talking about people who are already in the system. How about some of us who are new to this whole AI system?
Yeah.
Is there any way that we can also learn, or I don't know? Is there any?
What's your background, if I may ask?
My background is
so. What's your starting point?
Basically, information technology. That is why I have been a bachelor in information technology.
Yeah. Okay. So I would say I would advise two things to get started. So we live in an amazing world, and so you have this possibility nowadays of taking these online courses of super high quality. So you have some of the very best specialists of AI who have spent weeks and weeks creating courses to teach people with, say, an IT background, teach them the basics of AI. This is completely new. It didn't used to be like this even just, well, 10 years ago. It all started in 2012. So the MOOC movement is a very big help for people in your case. I think you can learn a lot just from taking online courses for free. You don't even need to pay anything. So there's a ton of material, courses, exercise, open source software. You just need a laptop and an internet connection, literally, and you are good to go. So I would say look out for AI courses which are sort of your level, being always, just a bit ambitious enough, maybe a notch above what would be comfortable, so to take you out of your comfort zone. And the second thing is try. So sit down and open maybe a notebook, a Colab notebook, I would say. So Colab is, you might know, oops, that's supposed to read research, obviously, not research. Colab.research.google.com. That's a type of tool that is free to use. That Google has made free, where you can type in some Python code and execute it. And crucially,
please come again. I couldn't hear you.
Sorry, I apologize.
You said we should. Okay, it's okay. From Colab Research. Okay.
Yeah.
Colab.
Sì, l'aveva mandato solo ai panelisti.
Oh, grazie. Yes.
Non si preoccupi, ho fatto.
Okay, sì, I've seen that. So sorry, I'm gonna correct the spelling because it's wrong. It's research.google.com. Let me just check that it's correct, but I think it is. Yeah, that's what that's correct. So sending it out now again with the typo fixed. And so if you open this is an environment that runs in your browser, and you can program there. You can start typing in some Python code, and you can import libraries. You can use open source libraries using commands called pip install. You can Google that. Most of the AI libraries out there are open source and free to use. So again, unlike 10, 15 years ago, you're now in a position that, so people like you are totally empowered. You can get going with, as I said, just a laptop and an internet connection. You don't need access to, university degrees or anything. You don't need to move physically. You just need to turn on your brains, be comfortable, and get going with these tools that I told you. And I hope that's going to get you going and help you do experiments.
Thank you, sir. Thank you, sir.
Very welcome. Anyone else? Qualcun altro? No, okay. Our time is over in this session, I'm afraid. So I'm gonna say goodbye to everyone. Thanks for listening. Bye-bye.